stop.
More convoluted, convoluted aliens. I don't know.
Yeah, I know. That's you pick a plot motivator like that can do anything, and suddenly the plot really has it just loses structure. It just kind of gets out of control.
Yeah, but that's exactly the problem. Right? Like, who was this guy again? Wasn't he dead already?
All right, we are just a minute after right now. What's our head count look like? Oh, it's actually looking really big. All right. Since we are tight, and I think they probably chop us off, they might give us some overlap, but we've been chopped in the past, and we can be long-winded. Let's get rolling. Is my doc still sharing? It is, it looks like, right? But I'm not in preview mode or
All looks good.
I was slideshow mode. That's the one that makes it easy. All right. Welcome. You're in the Bier working group. For all those of you in the correct time zone, congratulations. The rest of us don't get that. Wow, slideshow plays on its own. All right. So if you're here, you're in the right place. Note well. Please read. Please note. Note it well. Any questions? Okay, we're going to need some note takers so this stuff gets queued up. We have all those tools available right here in our Meet Echo UI. So can we have someone volunteer to manage Etherpad and take notes? This is the point where we assign people if we don't get people to jump up and help out. Anyone? I know it's early for some of you in the West Coast or even the US or gosh, the other half of the world too. Man, it can't be easy. But we're here and we got to do this. Zero. Anyone else even hear me? Nothing.
Okay.
Who do we got?
Thanks, Jeffrey.
Oh, fantastic, Jeffrey. Appreciate it. Okay, so we can move. Excellent. All right, noted. Jabber minutes. Got the Etherpad as well. Here's a current agenda. We are opening. Wow, that's so wrong. Oh, we pushed Jeffrey to the front because he's got to take off. That's right. Okay, man. I'm sorry, Jeffrey. You're not here for the next one too, but we'll have this recorded for you. I'm sure you're looking forward to seeing that. We have an implementation. We give him a good time slot. This is pretty exciting to kind of get some feedback on what we've done and what it looks like in a real box.
Excuse me.
Any other questions about things missing from the agenda?
Excuse me. The slides are not moving.
The slides are, oh, you know why? How about this? All right. Moving now. Can you see them now? Full agenda? Anyone?
Yeah, I see it.
Okay.
Yeah, I see it.
So we got 3 docs in the queue now, and the queue is gigantic. I think the one has been in there for months. So I was kind of waiting to see things go through to stage the discussion, but it looks like the queue's so thick, we're going to start pushing some other stuff that's been prepared as well. Just waiting for some feedback from other groups. Right now, we've got these 3 in the ISG queue, which is pretty exciting. Status. This is being presented, MLD. Let's see, LS Bier. Yeah, so according to the Shepherds, it looks like it needs to be updated. We're looking for Guyan to do that, and we'll move on from there.
The MLD
Comment?
extension.
Oh, go
Maybe
ahead,
just
Stig.
PIM here.
Should have PIM here. What are you talking about? I'm lost.
In the MLD extension, I'm presenting it today, but it hasn't been, past last call yet.
Yeah, right. This is just status right now. This is what's happening to it, right? It says IGMP MLD extension is in the ISGQ. Bier MLD is being presented in the meeting. Is this not correct?
No.
Had the previous in the queue there. Oh, PIM signaling.
Can you hear me?
Yeah, I can hear you now.
My apologies.
I can't hear that. Someone I think is speaking, but it's really, really faint.
Can you hear me?
And Tony, can you manage that and find out who it is? If I jump back to that view, I lose my slideshow.
Well, I'm seeing this
Hello, can you hear me?
microphone.
There we go. That sounded better.
Hey, Human,
Folks
yeah.
hear me now?
I hear you.
Okay, my apologies.
You hear me?
Again, I'm not sure
Hello,
if this is right or not. Can you guys hear me?
Yes.
hello,
Yes.
can you hear me?
I hear both of you now. Let's let one go at a time. I think that's Human, right?
Yes, it is.
Okay.
It's Stig. You want to go first? My apologies. I didn't mean to interrupt. Okay, so in that case, I keep talking. I think the team is the one in the queue. I'm not sure about MLD. I think that's what the stick was trying to bring in the. Yeah, so this is right. PIM IGMP MLD
Okay.
extension. I don't think that's the right draft, though, right? It's draft IETF Bier PIM signaling that is in the
Right here.
IESG. Yeah,
Right. This
exactly.
signaling. Right. This one is. I think what she's referring to is an actual PIM draft and IGMP that's in there that I guess has dependency in the Bier MLD.
Oh, okay. I see what you mean. Yes, understood.
Okay. BRLS extension, we have, again, we're looking for that to be revved. And PHP looks like it's last call and move on. It's one that's in the queue that we got response from. I think we have a Shepherd for, and I just was staging them out. So we'll start pushing those on through as they go. Same thing with EVPN, possibly next call. And we definitely need Shepherds for it as we move. We're waiting for a Shepherd review of Beer Ping. We need, gosh, HTTP response needs a Shepherd and V3 needs a Shepherd. Now, I've asked for Shepherds after each one of the meetings. I usually get 2 or 3 and it moves us forward. So here's my pitch once again. I want to participate. You want to get your hands dirty and involved in the process. This is a great way to simply follow instructions. There's a draft that, or is a RFC that goes through the process. Just to confirm, the document has gone through all the necessary procedures in the IETF working group before it's moved on to the ISGQ. And this document then, is just the document you author, confirming all those questions and giving any comments on the status of the doc, and that moves forward with the queue for the IETF to review before getting ratified and published. So please, I'll jump on the list again. I'll go through the number of docs and which ones. Some people just say, I'll take anything. Some people have some passion, want to grab one. That's great. Either way, whatever works, we'll make it work. So there's my pitch, and look for an email after this, and probably after my nap, and then I'll send some email out.
Greg, 2 things. So, okay, I see you're already putting that up. I'll be presenting tomorrow in BESS, so I will call maybe someone in BESS because those guys have deep EVPN knowledge, will volunteer to shepherd actually the EVPN extensions because it's hugely EVPN specific. I don't foresee any surprises, but it will be good to maybe get them involved if I find
This one here at the top.
Yeah. Mm-hmm.
Okay, got it. IDR extension is actually expired, kind of waiting around. We need authors to update this thing, and then we can, again, jump on a Shepherd and move. Looks like LSR extension just needs an update. I don't know what the status is. I'll have to dig in that to see, but they're definitely most likely connected. Any other questions? Doc gaps?
Yeah, on the LSR Ether, we'll really need an update if the authors don't step up. I think, we give it another meeting or so, and then we start to look for another set of authors to actually drag the stuff forward. We need that, yeah. Mm-hmm.
Oh, gotcha. So the authors that were actually engaged in it have just kind of moved on?
I don't know. We'll see.
Oh,
They
all right. Right. If we don't get traction, we have to move on. All right. Fair enough. All right. Next up on the agenda, this is kind of interesting. Oh, but I already have it down, so it's not going to help. I'll bring it here. Okay, wait a minute. That's the implementation, and we're going to start actually with Jeffrey. So the docs are not in correct order, but I'll straighten that out. And that's the Bier tether doc. So Bier tether is there. Tether is there. All right.
I lost your screen. You may need to reshare.
Well, no, I have to. I
Oh,
closed the doc I was sharing, and then that kills it. And I have to open the next doc, make sure I'm on the right one, and I will share it.
So can you guys hear me okay?
Yes, Jeffrey, sounds great.
you read fine.
All right, you see it?
Yes.
Excellent. All right. Next slide.
Yeah. So in this 0.1 version, I have updates to add egress protection. So today I'm just going to give it a quick review of this egress protection. First, a quick overview of tethering idea itself. Basically, a router that does not support in Bier, which we call a non-BFR, it may have one or more designated helper tethered to it. Typically, it's right next to it with a fat short pipe. It could be via tunnel as well. The helper advertises that it is the helper of a helped node. Helped node is typically the non-BFR, right? Yeah. And then the section 6.9 procedure in the architecture RFC, which is for post SPF handling of non-BFRs, we update that so that instead of replacing a non-BFR with its children that supports BFR, we replace it with the helper. If we know that that will not introduce loop. After that, the tunnel will be the traffic will be tunneled to the helper, who then tunnel to the downstream BFRs. That's the basic idea of tethering. And in the 0.1 revision, we introduce egress protection based using the tethering algorithm way to do the egress protection. Next slide, please. So at the bottom of this screen, this slide, so we have example topology. BFER1 and BFER2. CE1 is connected to both BFER1 and BFER2. CE2 is not only connected to BFER2. So BFER2 is the designated helper for BFER1, or designated a protector for BFER1. Now, when the BFER1 fails, in this case, it could be either the real node failure, or it's just that the only link to it is down. So in that case, we can actually consider it as a non-BFR. And then the its protector BFER2 will be considered as the helper. So with that, we actually don't need additional signaling besides existing tethering signaling. The BFER2 will just announce that it's the helper of BFER1, and the other routers will see that, and they realize that BFER1 itself actually advertises that it is capable of Bier. Then they know that, okay, this helper is for egress protection only. Next slide, please.
Do you see that?
Yes. Yeah.
Okay.
So here, the BFR1 is the point of local repair. So typically, well, in the working situation, BFR1 send the packet to that has the bit for BFER1 on was the BFER1 will send the packet to BFER1 directly, and that is you can see that's at the lower left corner, which has the BIFT for the BFER1. In that, it has an entry for BFER1. That entry has a primary pass, basically says send it to BFER1. And the backup pass says that send it to BFER2. I should say tunnel it to BFER2 here. So that backup pass is calculated ahead of time based on that advertising from BFER2 saying that it is the helper of the BFER1. Now, when BFER1 detects that the BFER1 failed, any in-flight traffic that BFER1 received with the BFER1 bit on will be tunneled to the BFER2. Now, BFER2 has its own BIF table. In that table, there is a BFER1 entry. And for that entry, the next hop has a primary pass and a backup pass. The primary pass is to send the packet to BFER1 here. Because when BFER1 does work, we do want the packet go to BFER1 and through the BFER1. Now the backup pass is that to decapsulate the packet and send it to CE1. That's because that BFER2 knows that it is the designated helper or designated protector for this egress protection. Next slide, please. It's worth to note that both CE1 and CE2, if they both need to receive the traffic, now when the packet is FRR'd, fast rerouted to BFER2, and that if that packet only has BFER1 bit set, then the BFER2 will only send it to CE1 after decapsulated. It must not send the decapsulated packet to CE2. That's why in this scheme, the PLR, the point of local repair, will not flip the bit that was set for BFER1. It will not flip that bit to BFER2 bit. That's what was done in another egress protection method. Now, also in the BFER2s, now if can we go back to the earlier slide?
Right here.
Yeah. So in the BIF table for BFER2, whether it's primary pass or backup pass, I did not draw a forwarding bit mask there. I want to point out that for that backup pass, which has the decapsulation action there, each bit FBM must only have one bit set for the BFER1 itself. And that is actually the general rule that any decapsulation branch must only have your own bit set, that one particular bit set. That well, I shouldn't say that it's a general rule that is already is explicitly spelled out, but at least that's my understanding. Next slide. Next slide, please.
2 slides or this one?
Yeah, just this one. Yeah.
All
The third the third note here, actually, I need to go back to the earlier slide again. Yes. I want to point out here that notice that in the BIP table for BFER2, in the entry for BFER1 here, the primary path is to go through BFR1, because when the BFER1 is working, we may want to go that way. Now, if somehow BFR1 detects the failure of BFER1 earlier than BFER2 does, then we will have a transient loop here. BFR1 send it to BFER2, and BFER2 follow the primary path BFER1 and send it back to BFR1. So that transient loop can be avoided if we don't use that primary path here. As long as BFER1 gets the packet with the BFER1 bit set, then you will always just do the decapsulation and send it to the downstream receivers in the overlay. That's to avoid the transient loop. I think that's basically my presentation here. It's just an update to include the egress protection.
Comments? All right, thanks, Jeffrey.
No, there are comments. Waimo, please, on the mic.
Got him. Okay, thank you.
Can you hear me?
Yes.
Yes.
Yeah, I have some questions. So last year we posted equals protection draft as an individual draft, and this draft, so Jeffrey proposed a new protection, equals protection. So this new proposal is added into a working group document. So it claims that it reused the helper, but the working group document that defines the helper is different from the protector, right? So in the egress protection, so the helper in fact is the protector, so it's a different concept.
It
So
is.
is better to explicitly use different term, for example, use protector, whatever, because if we use a helper, is confusing.
Well, if you need a helper, it's a good solution. If you don't need a helper, I mean, you are presenting your stuff today, right? Which is the direct egress protection. So both has merit, and we should talk about both.
So in addition that, because this new proposal is about egress protection, is a different topic. So
Yes.
I think this should be removed and then placed in a separate individual draft, right? Because this new proposal, even this technically, this new proposal have some issues. So I will send those issues in on the list, and because we don't have enough time to discuss those issues. Even so, so my main question is that should the author remove that egress protection part from a working group document and then place it into a separate individual draft?
Your point is valid, Huaymo, and I think if we could actually find a common framework to have one single document with all the ideas for the egress protection and then work on that, that will be the best outcome. So we don't have multiple documents flying for special cases.
Yeah, definitely. If we're talking about capability messages, right? We'd like something consistent if possible, and consistency as well in terms of where in the network are being protected. So we have a integrated set of tools instead of an overlapping set of tools.
So procedure-wise, if we want to separate this out to an individual draft or merge with another draft, procedure-wise, I am fine. But I do want to point out this is very well integrated with the tethering solution, because in the tethering solution, a helper which is Bier capable that helps a non-BFR, and when it is used in the egress protection, the helper becomes a protector, and it protects the protected BFER. And in fact, when we determine when to tunnel or when not to tunnel, that is basically treating as if that's the helps the protected BFER is Bier incapable as a non-BFR. That's how we decide when to tunnel or when not to tunnel. So it is indeed extending and the Bier tethering procedure to do egress protection. So from that point of view, I don't think we need or want to separate it out, but that's just my view. And if the working group decide that they should be separated out first.
Greg,
and we can have more discussion on the email list.
Greg, I think we should take it, but I think Huaymo makes a good point that egress protection being basically its own working item for all the different cases as one document may be actually a very good idea.
Yep. All right, just take it to the list. Good feedback. Thank you.
Note taking is running with us. We up to date? Jeffrey, because you were presenting. So please catch up on those notes. Thanks.
Oh,
yeah.
So I didn't realize I'm supposed to. The one reason I'm going first today is because I need to take off early.
Ouch.
So,
yeah. All right. So can you find another note taker? Put it in your lap. Who can jump up here? Jeffrey's got to take off. Is why he went early. Someone. I think MeetEcho needs a new app where we randomly select a participant and they become the note taker.
Yeah, dice. Throw a dice. Yes. Gentlemen, we need note taking. This is, refusal to perform. Okay, Greg, I will take
I see Torlis is on Jabber, so he's prepared. Torlis, can you do it for us? You there?
Push the MeetEcho button. There's no taking tool right there. I can't take note. I have to present. It's all integrated. So,
I'll take this one. I'm all right, Tony. I'll present this one, and you could take notes on it. We'll roll from there.
Okay, so we'll coalesce all these notes together. Fine. So I will put in. So that was presentation. Okay, I'm on it. Yes, thanks, Greg.
All right. So I'll keep going here as presenter. All right. So we got the next one up. I'm very excited about. Where did I find my tool? There it is. Share my screen. It unshares the screen. Bear with me. And resharing my screen. No, I've not changed my mind. And I want to give implementation. Wow. All right. I don't have my agenda in front of me because I switched docs here. Who's the presenter on the presentation?
I am here. Joe Matti is the presenter, but I would like to co-present with Frederick Rui. So can you please unmute him?
Sure. Who was that?
Frederick Rui from Renater.
I'm muted.
Unmuted? All right.
Yes, I would like to share my screen if possible.
No, Frederick, as I
Oh, you want to present directly? Okay, then I'll unshare.
Sorry. I was. Is it okay?
Well, as chair, you have a lot of buttons you can push. That was fun.
Oh, can you see my screen?
Yes.
Can you see the? Can you see this? So let's start, and thank you for letting us present our for letting us the chance to present our work here. The presentation is quite simple. It will present you the RAR free router Bier implementation we did so far since 2017. So the good news is that we have this Bier implementation on free data plane. And I'm not sure if you are familiar with P4, but we are using P4 BMV2 virtual switch data plane in order to learn to do our homework, and then we transpose the work all to the whole work we did with the Tofino switch, which came from initially Barefoot, now called Intel. And we also progress with a DPDK data plane. So I will be co-present this 20 minutes with Xaba Mate, which is the RAR router lead core developer, and I'm just the RAR project we are working both for Géant on behalf of Géant, and I'm the technical leader of the project. So real brief agenda. We really quickly present the project. Bier RC draft implementation and the experience, the Bier implementation experience we lead since 2017. A word about interworking, and one focus on loop and rolling topic with a Bier application, and a very small conclusion. So the RAR project, RAR stands for Router for Academia, Research and Education, and started in 2019. And the group focus was to simply try to couple a control plane with multiple data plane, and by interfacing the two, we can have a fully functional router working at different data plane rate. But basically, it will leverage the hardware capacity in order to provide some interesting some feature that are specialized per use case. So the idea is to the real idea behind a RAR free router is that it's one familiar platform that can be used to create multiple solutions, and each solution will address multiple use case in the research and education. Of course, it's not only about research and education, it can also fit your own use case as soon as it is compatible. When I'm talking about use case, it's simply because we are using one control plane, but multiple data planes. And depending the use case you would like to address, the data plane will be different. Whether you would like to have to use a pure label switch router as a P router with MPLS, you will go use a hardware that is able to switch, that is capable to switch 100 at terabits, sorry, traffic rate. But if you are using a small home office router, you will enjoy the DPDK data plane flavor that we can provide. In this situation, we have recently the team has recently implemented Bier, and this is the what we plan to present you today. So not just to give you some idea about what we did. The data plane we support now is P4 BMV2 Tofino switch. We are studying the possibility also to run our code on FPGAs. We have a P4 emulation already in our Git lab, and this emulation target are implemented using libpcap and DPDK. We are in the discussion with Broadcom in order to see how we can leverage NPL to apply our code to hardware like Trident 4 and Jericho 2. This is the P4 lab we are running in Europe. Since yesterday, we are connected to Chicago in the US, and from there we have the possibility to reach the whole research and education US area. So we are working with Tennessee University, Northern University, and Caltech also in order to provide this live P4 lab. We are using this lab to test the Bier implementation, where, for example, some nodes are hosting some bare metal server that produce source multicast source. Sorry, and we can also we can also connect a receiver on top of this green box.
I have a question quick. You just mentioned Chicago. That's StarTap, right? Is it still called StarTap?
Starlight.
Starlight now, but that's the like university and research education peering point.
Yes, exactly. Yes.
Okay, excellent. So actually, you have access to the entire I2 infrastructure, but those are the universities that are currently actively working. Excellent.
Exactly. This is the idea.
Excellent.
Please
Thank
go
you.
ahead, Xavier.
Sorry, nothing forget about it. Yes, sorry, my bad, my slides. So yes, the Bier implementation we have is at the moment focusing on the MPLS encapsulation. I know about the others, but currently, as far as I know, at least for us, the MPLS encapsulation is the target. And this is what FreeRouter have since Bier became RFC. In software data plane, that is when FreeRouter itself handles all the packets itself in the Java control plane and do the forwarding itself. This data plane supports all the B strings written in the Bier MPLS RFC. Moreover, it supports the B string domain. So I mean, when you have two Bier domains, one running on a B string length A and other on a B string length B, and the domain border router have two IGPs and have to decapsulate, and if it goes from the bigger to the lower B string length, then it have to emit two packets with two different SIs on the lower side, and the same on the backward direction, but obviously it won't duplicate the packets. This is in software. In hardware, we only support recommended B string lengths in all the data planes. We do that is the TPDK at Toshino and fully for education at BMV2. Regarding the control plane features, we have also from the beginning is the iSize implementation. It have no interoperability tests at the moment, but Wireshark nowadays decodes iSize LSPs with Bier extensions very well. So I am pretty sure that if one of you have something, then it would be interesting to see how it interworks. Regarding OSPF, we already had an interoperability testing which went quite well, and thanks guys, Tony and sorry I cannot pronounce the name but I had to. So thanks to Reaper guys for letting this happen. I mean the OSPF interop. Regarding the IGR, I mean the BGP with the Bier attributes attached to a prefix from a different domain or from the same, I mean AS or the same AS. We already have it. Obviously, the attribute type is a random value from the reserved part, but the population of the data plane and the computation is already there. So when the to be done field get populated, it will be the final version from our side. And more interestingly, we so our primary target is to provide an IPTV-like experiment in the field finally in our end-run in Hungary. So we went for basically for the PIM Bier draft, that is Not only concentrating on Bier because we will go with CPs, but they will be Ps in this case. So obviously I test with PIM, but also the same is true from this point. When I mentioned PIM, it's the same for IGMP. That is, from FreeRouter's point of view, it's unimportant if the join or the report came from PIM or IGMP. Frederick, next slide, please. Frederick, next slide, please. Thanks. Experiment. So,
two quick questions, maybe, Louis. Two quick questions. So one, Posen, I assume you are attaching Poland to PSNC, right?
yes.
Super. And all the P4 routers on Giant are now running Bier, actually your implementation?
Yes.
Wow,
So,
okay.
so the thing is that we will came out soon with a public only loadable image, and the data plane Toshino binary, that basically the forwarding code of the ASIC is just a 50 kilobyte Debian package that you can field replace. Not everything is pegged to the same. I mean, not every feature is pegged to the same only image because we have too many features to fit the ASIC. so you have to choose between the features, but we already built daily a Bier feature set that is an MPLS feature set plus the Bier forwarding and the IGMP and the PIM interworking from the data plane part. The software, I mean the control plane part is unlimited, so it is the same FreeRouter regardless which data plane you are using.
Okay, yeah, super. So that is a call to all the vendors here on this call. This may be the next interop lab for where you can cheaply interop Bier with a lot of different stuff. Excellent. I think we lost the screen share. Greg?
Answering to your question explicitly, yes, we have a specific site where I would like to ask all the vendors here that please find us or let us find you and let's do the interop.
Okay, I granted the screen again. Yeah, so let's continue. Time is precious.
Okay, so basically how it could happen. When you came out with the draft, I started to study it and started to implement it on my home network. All the underlined words and links are clickable here. You will see that it is a small home network, but about 10 or more routing nodes, and all have virtual routers within. In some, basically a 30 to 50 nodes, depending on which day is it on the week, basically. But it's an ESP-like setup here. That is, I run two root reflectors and the MPLS VPNs, both layer 2 and layer 3, and so on. So a normal ISP, but with a very small one in a small household. And obviously have my own needs, like to have a two-zone music here, and it quickly turned out that the only perfect solution on over Ethernet is a real broadcast. So I started studying initially initially PIM, then MLDP, and nowadays Bier. Obviously, when I didn't have a data plane, I ran it in software switching, and I saw my CPUs matching, but nowadays with the DPDK it's gone. Frederick, next slide, please. No, please don't. Please back. And yes, thanks again for the Juniper guys who let it happen. Recently, we had the first real interop test over OSPF, and I think it was just my bad that I didn't proceed it toward. The thing is that it really interworked. You will see, hopefully in the next slides, I've got an access to an intermediate image. I had some screenshots from it. Thanks. It is not one, but perfect. Some words about it. It is a test bed. If you heard about dm42.net, it is a community movement to let young people experiment with BGP. And I joined it so early. And the thing is that anyone can peer to anybody over here. And my own public dm42 test bed got a Bier draft idea that is a BGP. So got this feature about 2 years ago when I implemented the BGP part for the Bier. Since then, anybody who joins the dm42 on my nodes or peers to me over a GRE or anything, it's public and anonymous. You can interrupt test basically 0 to 24 hours. Frederick, next slide, please. Yes, it is the first screenshot of the Juniper interrupt test. On the upper half, and please, can Juniper guys unmute you? Probably you will have better comments than me. So the upper half on the screen, you can see how the VMX decoded the OSPF LSAs that I sent to him. Basically, the VMX, as you can see on the bottom of the screen, was surrounded by two free router VRFs in this case, from the left and from the right. I will name that. I will call them in this name on the proceedings. Frederick, next slide, please. So the Bier forwarding table from the Juniper's point of view, remember the left and the right were on the G001 and G002. And from the left, which is the one, the VMX here, the 222.111. And it picked up the prefixes perfectly, immediately, without any hacking on it. And on the next slide, you can see that the BFR ID embedded, attached to the, sorry, please back. Okay, no, okay, perfect. So on the bottom of the screen, you can see that how VMX attached the BFR IDs from the prefixes to the next hops, basically. But yes, I think it is attached to the next hops from FreeRouter's terminology, but I think Juniper have a different terminology for it. Never mind. And the other thing you note that my implementation advertises random labels every time, and Juniper picked it perfectly from the start. And every time I reloaded my side, it worked fine and repopulated the tables. And on the middle of the screen, the 123, the /60 is the Juniper's own loopback address in this domain. Obviously, he didn't allocate it for himself a loopback label, or I don't know how to call it. Frederick, next slide, please. Yes, detailing the forwarding, the Bier forwarding table with the next hops from the Juniper's point of view. This is the B string on the wire, basically dumped to you in binary. It is a very, very useful thing because when you open the packet capture and you convert back the binary to hex, it is the same what you can see in the after the Bier header, in the B string part. And again, the next hop associated to it and the outgoing interface. Frederick, next slide, please. This screenshot is my buggy sheet, sorry. So the OSPF from the left and the OSPF from the right. Basically, nothing interesting. I used the 111.111 and 111.222. I enabled the Bier on the area and the traffic engineering. I'm not sure if Juniper checks for it or not. I enabled it just for sure because because I really didn't went to check for it. Later I did anyway. It's just when the screenshot was taken. Yes, and the loopback from the left of the Juniper and how I attached the Bier index to that prefix. Frederick, next slide, please. Frederick, next slide, please. Yes, it is with the set the filter from the Juniper's right side, but still from FreeRouter. Basically, what you can spot here is two tunnels. It's a FreeRouter specific thing to be able to quickly test. The idea here is the same when similar when what you do when it comes to point to multi-point SVPT tunnel. Basically, you set a dummy destination with the FreeRouter internal stuff. Don't care about it. But on the domain name part, you can list more IPs, and FreeRouter will go for the BFR IDs and populate the header with them. I mean the bits set with them. So basically, I can do a static multicast threading if I want in this way. It is here for just for this or to testing. In this case, with the Bier Juniper interoperability, I only set one bit from the Juniper's left and right, and I assigned an unicast IP, as you can see, 333. And Frederick, next slide, please. And basically, I did nothing but ping the through. No, it's not the slide. So this slide is about how FreeRouter saw from Juniper advertisement from left and right. And more interestingly, on the left and right, I heard clearly the other side. I mean, on the left side, I can see 222 that 123, which is Juniper's own loopback address, and the advertised label 123, which I configured to it. And which I wanted to see here is the 222, which is the Juniper's right side. So Juniper advertised, I mean, flooded the LSAs through itself to the left, which is basically normal, but I wanted to see it. And finally, the forwarding table from FreeRouter's point of view on left and right VRFs. No, unfortunately, I did a mistake and I left the V1 VRF. Frederick, next slide, please. Yes, so how a specific label looks like in FreeRouter's point of view basically is the same what you have saw already on the Bier's on Juniper's Bier forwarding table when Juniper populated its B string and assigned it to a next hop and an interface and so on. But it's from the FreeRouter's. I think it's from the left, but I can't spot it right now. Yes, it's from the left. It's on the forwarder left point, column 4. Frederick, next slide, please. Yes, then I cleared the counters and sent some packets through. And then I checked the counters. Juniper was connected, I mean, Juniper's G001, G002 was connected to PV ether 1 and 2. And the thing is that I sent 70 kilobytes and I received 70 kilobytes, and the backward direction is the same. That is, I saw a single bit addition or deletion from the packet. That is, the forwarding happened perfectly from my point of view. Later, obviously, I did some other testing and captures on the interface, and I spot nothing, really nothing. Frederick, next slide, please. Yes. So finally, the last slide from my part is a bit of poor man's Bier forwarding, because we went now with P for data plane, and here I had two decisions. To be honest, I didn't like none of them. The worst decision from my point of view, if I make the real ending of the B string with the calculated B string, then I send out the packet if any bit remained 1, and I do a not end on the packet and recirculate the packet if any bit remained 1. But this thing would involve recirculation, which if I had to recirculate to 3 peers, I mean, if I had to recirculate 3 times for 3 very different peers, then it would divide the Bier performance. Instead of this, I decided to unroll that forwarding group for the ASIC, because then this extra calculation in the SPF, I was able to use the built-in flooding mechanism of the P4 language, which is basically optimized for layer 2 flooding. And the thing what I described here is basically this. I don't want to explain too more, or only if you are very interested in it. The thing is that I think you will see some low-end ASICs in the future that would decide if they go with R-rolling or recirculation. If you have any clever mathematics over there, I would like to see a draft and the proof that how can this unrolling be done well. I mean, I tried some things, and finally I have now an idea that if I fully disable equal cost multipassing calculations for Bier, I mean the prefixes that have a BFR ID, and I need to do the Bier calculation because the operator enabled it, etc. Then I do a second calculation with only the first possibilities populated, and add with this solution, which is far from perfect, obviously. I reached the state that the last hop do the pocket division. I mean, in this case, I usually saw R1 doing the replication, and the 2 replica proceeded on R1, R2, R4, and R1, R3, R5. With the tricks I tried, finally I reached the point that R1 does not duplicate the packet, but it basically forwards with R2 with 2 bits set, and R2 basically duplicates the packet to R4 and R5. But it's again a poor man's solution for to overcome the forwarding limitations. Yes, question? I see.
Yeah, Tony. I think we had a chat, out of band on private email about the whole thing. There's a lot of trade-offs, right? The Bier forwarding path allows you to parallelize or recirculate or whatever. There's a lot of implementation depending, what you optimize for: cost, speed, fan out. You can do all kind of trade-offs. For the ECMP, I mean, I'm not saying too much, but architecturally what we did, we really have an IGP next hop or whatever provides the next hop underneath Bier. So we do not try to do the next hop ECMP in Bier. We actually fall back on the IGP next hop, and you see that also when you look at our reps in the CLI, that we really use IGP. We use protection, we use ECMP, and so on architecturally. But also, of course, it's an indirection that you have to provide.
Yes, you are absolutely right. And this problem, I think, can be can occur without ECMP easily. I personally spot it on an ECMP topology, and that's why I came up with this slide and this drawing, because that's what I use in my home network, basically, that I have 2 P routers and 2 P routers attached to the loudspeakers. I agree fully that the forwarding solution we are using can result suboptimal duplication points without ACMP also. It's absolutely true. But from my point of view, what I am planning to, I mean, the forwarding ASIC code is tuned to at the moment is to avoid as much as possible recirculation, and it's true. So we really do not recirculate for Bier replication, but then I had to unroll. That's it.
Yeah, of course. Yes. I mean, recirculation, we both know, is very, very costly ASIC wise, but you know, it's also very costly to carry a lot of packet descriptors to the chip. So no free lunch. Yes.
Yes, yes, absolutely. The only thing that I am aware of, and we need to document with this thing, is here in my testbed, I run it over. So basically, all the nodes have a 4 or 5 or 8 maximum gigabit connections to a common layer 2, and the routing nodes here are rooted on the stick configuration. When it comes to the hardware, and when I have to replicate 2 packets to the same port, then it obviously will overload it. So that's the only thing we spotted. But since then we had the chat, we have the chance to measure it. I mean, not fully, because we have some limitations with the measurement and so on. But I saw it performing at 50 gigabits already, which is not bad after all.
Well, Europe is living now in Bier, because the first hard rock music has been piped over Bier network in Europe. Excellent, congratulations.
Thanks. Frederick, please continue. Frederick, we don't hear you.
Sorry, can you hear me now?
Yes, yes.
Sorry. Key takeaway slide. Well, everyone is doing it, but we just wanted to mention that we are also automating all the testing related to all the feature, and Bier is included. You can fill the whole list of tests in the project page. Essentially, it's roughly 2,000 tests that are daily, no, not daily, but automatically triggered each time the new code is committed into the Git. In the end, you have a freshly image like a Junos install or a Cisco or whatever firmware install in 1.9 installer that will let you handle that let you transform your P4 router or your P4 switch into a full-fledged router having tremendous
not full-fledged.
See, almost. And one thing that is important is that we have a aspirant that help us to where you are using RFC conformance test. Next step is to provide P4 profile calibration that Xaba mentioned, which means that each image we have a profile. One will be dedicated to Bier. One can be pure MPLS. The other one can be SRv6 only. And DPD, we have a P4 DPDK data plane that is in operation, already used in Spain by University of Murcia, and soon University del País Vasco in Bilbao. And we would love to have your feedback if any one of you is interested. So that being said, you can find some useful link, which are the project page, rarefreerouter.net. We have a blog where you can find a lot of interesting articles that will help you install your home router with our product, which is what I'm using right now during this VC. And we have also docs.freerouter.net where we are trying to provide a control plane documentation related to that. If you want to reach us, you have a RAR user mailing list, RAR dev if you want to contribute and add your own your bits and bytes into the control plane, and also the P4 data plane. You are very welcome to contact us. And
Just a moment, an IETF specific thing here is if anyone of you have something that works or barely works, please contact us and we are more than happy to make some interrupts.
yes, thank you, Xaba. And you can follow us on our Twitter account where we are pushing frequently new progress articles and experiment. And special thanks to all of this our organization, which make everything possible, because we really did not reinvent the wheel, but we assemble a lot of existing working technologies coming from this whole organization and sub project. So thanks. Any question?
No questions on the mic?
You've dumbfounded the room.
Yeah, so I think a more clear call to action cannot be given. We know there is a bunch of vendors out there implementations. This is a free, pretty sizable test bed. Obviously, the P4 stuff is available. So there's barely excuse not to run Bier.
All right. Ken, thank you. That was fantastic.
Yeah,
Appreciate
thank
it.
you very much. Very, very much. Yeah, excellent.
So next up is Stig with Bier MLD.
Can I just have a quick question on this stuff?
Oh yeah, go for it, Torres.
Does anyone know? I mean, I forgot the name of it, but you know, isn't there also an equally large test bed in the US? Are you folks? I mean, I'm not aware much of what goes on research there, but have you folks from Geant heard anything from the US side?
Yes, we were contacted, or we contacted, I cannot recall the history perfectly. So I usually mailed a guy from ESNet, and he gave me an access to a Bastion server where from he told me that I have an access to a P4 switch somewhere in the States in a university campus. And that site, as far as I know, somehow connected to our test. But that is, if you are really interested, please drop me a mail, and I will find the guy, and I will connect you with him. And at this point, we will be.
Oh, they don't talk to me, so that's why I'm asking here.
Oh, I see.
Oh no, they're not allowed to talk to us because of the government.
Ah, I see. At this point, I will make the communication, or if you have a virtual image, then I can run it obviously, and I can make the interop, or we can have a GRE or anything. I am really on to.
Oh, I was just curious whether the US folks in research are also picking up the ball.
Yes,
No, I only know one guy from the ESNet and the other from the university. I hope the university guy you are allowed to talk to, don't you?
No, they don't want to talk to us, or else they are losing funding when they talk to somebody from years away or far away, right? So basically,
I see.
Yeah.
Okay. But I know that there is a P4 switch that is surrounded by Juniper and Cisco boxes, and probably others. I saw them in an LDP, and if you can somehow provide an image to them, at this point we can perform a very good experiment, because from Budapest site we regularly can inject broadcast from my house. That if you saw on the presentations link, I did a demonstration where I had the music broadcasted to 2 rooms, but it is available in all the POPs in the testbed. I think it's the same for the States. So basically, when I press the play button here, you hear the same at the States.
Thank you.
Through Bier.
Just to be more factual, with respect to US area, they have a P4 testbed, and we plan to connect to this testbed via Chicago.
Fantastic.
Yes, it is another. Yes, and the third one that I heard about, the ASNS guys are cooking something on top of SmartNICs. But I didn't want too far to ask them what they are planning to do with that.
All right, we are crunched time-wise. I wanted to give you guys all that for certain, some of this connections and getting connected and understand the links. It's all there in the presentation. You can download, take it to the list, and we can hopefully get more people connected. Any other questions or comments about it? We're there. Excellent. Thank you, guys. That was fantastic. Stig, you're up.
Thank you. Thank you.
Yeah, hi, is my audio working?
Yes, it is.
Is my audio working?
Yeah, your audio is working. I will share the doc here.
Thanks.
Is my audio working?
Yes, it is. We hear you. Stig, we hear you. You do not hear us? Turn your mic up. Turn your volume up, Stig. Wow. We're having trouble here. Let's get a hold of him directly. We hear you.
Someone is telling me that you can hear me. It's just that I can't hear anything for some reason while I'm talking.
Correct.
So I'll just go ahead.
All right.
At the moment, and you can tell me whether you can hear me. Okay. Okay.
I can hear you, Stig.
So I'll just go ahead.
Yeah, please.
So go to the next slide, please. Okay. So yeah, this slide talks about the current. It says currently the source address is assumed to be a Bier prefix, but that's actually the previous version. Sorry about that. So we used to get the Bier prefix by looking at the source IP address and then somehow knowing the subdomain so that we can figure out which Bier ID that refers to. But that's kind of a hack. And we figured later that, well, we could get this info from the Bier header, but that's difficult when we have basically something operating at layer 3 or above layer 3. So we wanted to do the same as in the PIM draft to explicitly specify the Bier ID, Bier prefix, and subdomain ID in the message itself. So we got this generic IGMP MLD extension mechanism now defined in PIM. And that is something that we are using now in this draft. So the PIM working group draft, past working group last call and publication has been requested. So hopefully that will move on. Next slide, please. Okay, this is just from that PIM draft that shows how the generic mechanism works. So there's a reserved bit indicating that this mechanism is being used. And then what is defined as the auxiliary data section in IGMP version 3 and MLD version 2 RFCs is being used to contain this extension. So in this report message you see here, there is this extension part at the end of the usual report. Next slide, please. And this is what the extension looks like. It's basically a list of TLVs. And then it's up to other documents like our document to define the types that we need. Next slide. So this is the proposed extension in this draft. So we need an extension type from IANA. There is a length that will be either 7 or 19, depending on the address family. And then it's the subdomain Bier ID and Bier prefix. So one thing here is there's no alignment. We can fix that if you like, but in general with these TLVs, there's no attempt at aligning. So even if this one was aligned, it would be a problem if the previous TLV was not aligned, like the length would not be a multiple of 4, perhaps. But I don't see a reason to be aligned here. Next slide, please. So yeah, it's a little bit difficult. I can't hear anything while I'm talking, but I'm gonna turn off my microphone here now. But at least as far as I know, this document should be ready for last call. I don't have anything else, at least that I'm aware of, that should be added. Thanks.
So let's just take a stab at the room. I think, where's that tool here, if I can find it? There's a voting tool here. Oh, here we go, on top. Countdown.
Okay, I'm implementing. Sorry, implementing.
Show of hands tool, there we go.
Yeah.
So this is just, we are on, this is the Bier MLD doc. Okay, that's what I'll call it. All right, I just started a session, see who can just get a see of the room here, and we'll take it to the list later. Who thinks this doc is ready for last call? So what do? We raise hand? How do we do this? There we go, here they come.
On the voting button should have some funky color, and there is a raise hand, do not raise hand at the top.
Got it. See the raise hand at the top now. All right. We got 7 and growing. 8. All right. I think we got a good sense of the room. We'll take it to the list and hopefully move this thing along. Thank you, Stig. Appreciate it. I'm going to end the count. It's in the notes. There we go.
All right. Thanks,
All right.
guys.
Did you say next slide? I think Tether already went. We are at MLDP signaling over Bier Human.
Yes, can you guys hear me?
Yeah, we can hear you. And I'm bringing up the deck here.
And I can hear you guys, so that's a good sign.
Yeah.
Right, going the right direction, huh?
So you will hear the jokes we crack about you while you're speaking. I'd like to speak.
And wow.
All right, perfect. So this is just a refresher of this draft. First thing first, I want to give a high five, kudo, whatever, to Sandy. She actually had a look at this draft and caught a couple of mistakes. My brain is kind of fried with this COVID stuff in North America. But anyway, thank you very much, Sandy. I appreciate that. Next slide, please. Next slide, number 2, please.
What's it do? It says goes 1 to 4. And they're all called 4. So what do you see?
I see a slide number 1. Okay, thank you very much. So just a little bit of background why this draft. We are seeing some of the operators, they want to upgrade their network to a Bier infrastructure. They usually start with upgrading the core to the Bier infrastructure or part of their network. And basically this draft, exactly like PIM signaling over Bier, brings a mechanism that they can grab a part of the network and replace it with Bier without doing any upgrade on the other part of the network, which is running the MLDP point-to-multipoint tunnels. It's a very simple way of grabbing your network and upgrading it to a Bier in different segments of the network. Slide number 3, please.
Can you see it? Feels like this is taking more time.
Oh yeah, I think there's a lag. Okay, so basically the draft is very simple. It uses the RFC 7060. That RFC has been used to tunnel MLDP over other type of domains, including RSVPT domain, etc., etc. So we are using the same track here. Basically, the TLDP is stitching, if you will, the two access MLDP domains together. We need to find the EBBR and IBBR. Just a refresher for the folks out there. The BBRs are the Bier boundary routers. So the EBBR is the router closest to the source. The IBBR, the ingress BBR, is the router that is closest to the host, if you will, or to the leaf. And this is exactly the same as the PIM signaling draft. So the mechanism to find the EBBR, again, exactly the same as the PIM signaling draft. There are multiple mechanisms that can find that EBBR router. When the EBBR router is found on the IBBR, you could actually set up your TLDP session to the EBBR either manually or via automatic mechanism that is beyond this draft. When the session is set up, the TLDP session is set up, as I mentioned previously, it just stitches the two MLDP domain over the Bier domain. Slide number 4, please.
Hit it.
So while it's loading, I'm just going to go ahead. So from the data path perspective, the egress boundary Bier router tracks all the FEX, MLDP FEX, and it actually builds a table, if you will, of all the IBBR routers, the routers that are Bier boundary routers that are closest to the leaf, that are interested in that FEC. And it will actually grab that signaling information and send it upstream to the root router. And when the traffic comes back, the EBBR actually encapsulates the traffic, the MLDP, the MPLS traffic over a Bier and sets all the bits in the Bier header appropriately based on the downstream Bier boundary routers that are interested, and it shoots out the traffic over the. Actually, I think. Sorry, I think you need to go to number 4.
They're all labeled 4.
Okay,
And
so to
there's,
5. My apologies.
Yeah, there's
on the side
1,
there's a
4,
different numbering than the slides.
4, 4. This is the last 4, the third or fourth 4. If I go back to the full view, we can only have 5. Only 5 slides.
The slide that says data path traffic flow. That's a good slide.
Okay.
Thank you. Thank you very much. So that's the slide I just explained. When the traffic comes back from the route, it gets encapsulated into the Bier header, and it goes to all the egress Bier forwarding routers over Bier, and the egress routers remove the Bier header and just swap the LDP label and just shoot it to the leaf routers, if you will. Last slide, please.
It's just the adoption call.
Well, no, and that's the part that it was
That's the last
corrected
slide.
by. Yeah, so we are not asking for adaptation. Basically, it's already been adopted. Thank you very much, working group.
Yes,
What
it
we're
is.
asking for is if there's any comments, and we are hoping for a last call. Yeah, this is the wrong version. My apologies. Sandy has actually uploaded the right version.
Of the deck or the.
Yes, the deck.
Okay.
There is a newer version that Sandy
I just
was
grabbed this
kind
off
enough.
of the tools. I just pulled it off the tools. Should I grab it on the deck somewhere, or are we cool?
I mean, I did my explanation. I don't think we can.
Yeah.
We need to waste
Good.
any more times. The only
Let's do a
difference
vote
is that.
test. I mean, if you think this is ready, let's just get a sense of the room. I mean, I hope people have read it, but at least so MLD signaling.
Sandy's on the mic. Sandy, please take the mic.
Go for it, Sandy.
I don't want to comment for this draft. I just want to say the materials has been uploaded. Maybe Greg and you need to refresh your
Yeah, could then refresh.
yeah
All right.
web.
So let's
Yeah.
just get a sense of the room to see where we are. People think this is ready for last call, and then we can take to the list.
And
Votes
while
above.
people are voting, we have to pronounce deep appreciation to Sandy as secretary. She was saving our bacon all the time.
Always.
Yeah, uploading, making agenda, everything.
All right, we got votes coming in. All right, slowing down. We got 5. We got a handful. I think it's definitely a sense of who's read and replied, no reject. We'll take this as a list and start moving stuff along.
Maybe ask who read it.
We're running out of time.
No, that's fine.
Either way, we'll get feedback on the list.
Okay.
All right. Next. I'm not going to save that.
I think it will be I.
Next is OAM.
Yep.
And presenting.
Excellent. Thank you. Okay, we can go to next slide right away. Okay, the one document that is missing from this list is the recently work group adopted document on BFD, and I really appreciate the support from the group by adopting this work, and it's progressing. What I wanted to bring up to the discussion and get your feedback are these 4 documents. It started a little bit backward. We started working on performance measurement using alternate marking method, and thanks to Alvaro for his review comments. We worked on addressing and documents posted the version, and really appreciate the feedback if we address the comments. But what's important that was pointed in the review that the document refers to the requirements document, and it doesn't seem very logical to advance the solution before the requirements being advanced. And we believe that OEM requirements document has a value. It might have, well, some consider it to be only just as a historical value, and if it's informational reference, it would not affect progress of standard track, to my understanding. So there is this way forward just to leave this document OEM requirements in its current form, or work on it if there are any comments, recommendations to improve it, and then in the meantime progress the solutions to publication. The other way around is to complete the work on OEM requirements to publish as informational document, and then as it progresses, move forward with the solution documents, such as listed here. Performance measurement using alternate marking method, which is a hybrid measurement method according to RFC 7799. Path MTU discovery. I know that we have another solution, and we discussed it, and we, I believe, agreed to have documents separate, not to merge them. And then Bier ping. This is currently in expired state, but we are discussing working on update, and it should be published in a reasonable time. So with all that said, I looked and I believe that requirements, performance measurement, and ping, they do have volunteers who agreed to be shepherd, and really thank you guys. Path MTU Discovery is still looking for shepherd, and if somebody volunteers, I promise I will owe you one more shepherd document. So with that, open to your comments, questions, and suggestions.
Got one chat. Oh, that's just a vote. No, I think we're clean. Any other comments? So more requests for shepherds. All right. Thanks, Greg.
Yes, and actually, just the direction. So what we will do with the documents, how we'll progress them.
Perfect.
Okay. I can shepherd that. I'll have a look at it.
Yeah. Let's move. We got 30 minutes left.
I will write you. I owe you one.
Sorry, I was in another chat. The agreement is to shepherd which draft, Human?
Ping.
The one that was just.
No, I believe the ping has. I believe I'm looking for shepherding MTU Discovery.
Breaking up completely.
Oh, okay.
Hi, everyone. Can you hear me?
Yes, we can.
So today I'm going to present the IETF route. Next slide.
Human or Greg, please send me a message which draft you were shepherding. Sorry, one or yours.
So this draft will provide a faster protection for BATE. So basically, faster protection for transient node in BATE domain. So this protection will not have per flow states in the network core. Next slide. So for the BATE, we have two types of bit positions. One type of bit position is for egress node. So they call the local decoupled bit position. Another type of bit position is for adjacencies, for forward connected adjacencies. So here we use a number plus a prime to represent these kind of bit positions. So for any BFR, there is a forwarding table. So this forwarding table will have forwarding entries for all its adjacency bit positions. For example, for the forwarding table on node B, they will have 4 entries because B have 4 adjacencies. One is from B to E, which is indicated by 2 prime, and then another one is from B to C, is indicated by 4 prime, and so on. So in order to provide faster protection for any transient node, so we just extend each entry in the normal forwarding table with a FR entry. So this FR entry contains a flag we call the FPA, which is short for FR protection active, and then the number of backup paths. So this backup path is for when one next hop fails, the backup path will be from this local node to the failures next hop. So in normal operation, the normal forwarding behavior will be applied. So when one node as a transient node fails, so the FR entry will be used to use backup path to send the package, get around the failure point to the next select hop. So next page. So here we have more details through an example. So here we have a path from A to destination D and H. So the path is identified with the green. So we have two branches in this path. One branch is from A to G to H. So another branch is from A to B to C and to D. So in normal operation, so any package with this path will send it to these two branches. So that means from along the upper branch from A to G to H, and then the package will also send it to along the second branch, which is from A to B to C and to D. That's normal operation. So when we have a failure of a transit node, for example, when C fails, in this case, so the package will continue send along the upper branch, which is from A to G and to H. But for the second branch, so when node B detects the failure of C, the flag for C entry, FR entry, will be set to 1. So in this case, the FR entry will be used to forward package to around the fatal node C using backup path from B to D. So here, backup path is from B to G to H and to D. Before send the path using backup path, the node B will remove egress bit point 4, which is for H, because this 4 is on the backup path, but this 4 is not on any branch, path branch starting from B. So we need to remove this bit position 4. And then we add backup bit position for backup path. So with this modified bit string, so the package will be delivered along the backup path to D. So next page. So this is an updated forwarding procedure for support BAT FRR. So for next hop node N, if this node N is a transit node of a path, so the procedure will check whether this node N is failed. If node N is failed, so the node B, for example, B will remove bit position for the adjacency to node N. And then it will remove those kind of egress bit positions if that bit position is on a backup path, and then also, but not on any branches from PIR. So after removing those bit position for egress node, and then the PIR will send the package along the backup path to the next hop on the path. So this is through cleaned up a bit position for the adjacency from N to N select hop, and then add the bit positions for the backup path. Then the normal procedure will be used to forward the package along the backup path to the next hop. Next page. So this pursuit code gives more details about the upgrades. So basically, the highlighted part is the part for supporting the BAT FRRs. Next page. So we just would welcome comments for this draft.
So first question, Waimo, I understand correctly, this is updating only the Bier TE path, right? Forwarding path.
Yes.
No,
yes.
no, right. Yeah. So my comment is, yeah, well thought out, and since we have to study the architecture, probably necessary. Toles is probably the best judge of that. Thanks for the work.
Thank you.
Excellent. Thank you. All right, moving on to the next deck. It is T-egress protect. Same presenter. Oh, you've got a stack of them
Yeah.
here. Perfect. I'll just queue them up here for you. To egress protect. It still makes me start and stop. Sorry. All right. Got it?
Yes. This is about BAT egress protection. Next page. So this will provide fast protection for egress nodes in the BAT domain. So this protection also not have any per-flu states in the core of the network. Next page. So basic idea is that first we need to configure the backup egress for protect egress. So after this configuration, so the information about which one protect which one will be distributed to the direct adjacent node. So those adjacent node will extend the forwarding table, Bier forwarding table, so with the backup entry to protect primary egress node using backup egress node. And then in the normal operation, the packet will delivered along the normal path. So as soon as a PRR detects the failure of its next hop as an egress node, so that PRR will use extended backup entry to forward the package along the backup path to the backup egress node. Next page. So this gives more details about the extension to the bit forwarding table for egress protection. So basically, for node X, so for each of egress node connected to the X, so we just extend that entry with we call the backup entry. So this backup entry will have a flag EPA, which stands for egress protection active, and then the backup path, which is from local node to the backup egress node. So for example, here we have the extended table, forwarding table on node C. So node C, we have egress node D. So D is protected by H. So for the forwarding entry with next hop D as an egress node, so we will have a backup path from C to this backup egress node H. So backup path is there. So similarly for node F, if node F is the egress node, and then we have a protected node for node F, for example, is E, and then we have a backup path from C to E. So in normal operation, so the normal part of this forwarding table is used to forward the package. So when one node as the egress node fails, then the PRR will use the backup entry to forward the package along the backup path to the backup egress node. So next page. So this give more details using example. For example, we have paths from A to egress D and F. So in normal operation, so the package will deliver from A to B and then to C, and C will deliver package to D and F. So when egress node D fails, so node C will detect its failure, and then the flag EPA for the entry D will be set to 1. So in this case, C will use backup entry to forward the package to D through the backup path. The backup path is from C to H, and then the package will send it from C to H, and then H will deliver the package to the destination CE. So next page. So this gives more details about the procedure updated for support the egress protection. So basically, for a node N as an egress node in the package, so the procedure will check whether this node N failed. If this node N failed, and then we'll remove the old path from bit string to that egress node. And then we will also check whether this bicap egress node is already in the past. So if it is already in the past, we don't do anything. If the bicap egress node bit position for bicap egress node is not in the past, and so we just send the package along the bicap path to this bicap egress node. Next page. So this pursuit code gives more details about the updated procedure, which is highlighted part for support BATE egress protections. So next page. So we would like welcome any comments for this draft. Thank you.
Any comments? All right, thanks. We'll next to the next one, which is FRR.
Yes. Yes.
Oh, that's right. It's not going to show it. I got to quit and start over. Sorry. You're on.
So this is about the Bier fast array route. Next page. So I would like to thank you for those people for their valuable comments and suggestions. Jeff and Daniel and Xuesong for their valuable comments, and then I addressed those comments and I made the updates for the draft. So the main update is that we changed the status of a draft to experimental, and then in the draft we describe in details about the difference between the existing draft and our draft, and then we add some text talking about compressing the FR forwarding table. Next page. So the difference between the existing one and our draft. So the existing draft, the idea is that they call the tunnel-based FR. So basically, for when next hop fails, so the PRR will tunnel the package to the next hop. That's the basic idea. So in more details, the Bier forwarding table will have 2 forward entries for each egress node. They're called primary forward entry with the primary next hop and the primary bit mask. For bicap forward entry with the bicap next hop and the bicap mask, bit mask. So when one node fails, so this node will be considered as a primary next hop. So any package which is to be sent to the primary next hop, the special primary next hop, will be forwarded using the bicap entry. So with the bicap next hop and the bicap mask, bit mask. But for all the other packages, those packages will be forwarded using primary forward entries. So the issue is that because all those primary entries, the primary next hop and the primary bit mask, are computed using the topology before the failure. So after this failure, all those primary next hop and the primary bit mask need to be recomputed and updated. So before this new computation or recomputation, so all the other packages, some of all the other packages maybe get lost because of those kind of inconsistency. So our draft resolved these issues. So the idea of our draft is that we, based on the LFVs, so when next hop fails, we use the LFA backup next hop. In addition to that, we use multiple forwarding tables. We call the FR forwarding tables. So each FR forwarding table is for one next hop. So in this FR forwarding table, it will already consider the failures for all the bit mask and the next hop. So when one next hop fails, so the FR forwarding table for this specialized hop is used to forward all the packages. So next page. So we're also talking about compressing the FR forwarding table. So before compression, the size of a table is the number of Bier equals nodes. So after compression, the size of a table will be the number of labels minus 1. So after compression, so the two proposals regarding to the memory use will be in the same level. So sometimes this one will use more, and then sometimes another one use more. So next page. So any comments are welcome, and then we would also consider maybe adoption. Any ideas?
No comments?
Any
Right,
comment?
So as workgroup participant, not chair, well, I originally didn't think much of the whole idea because pretty much IGP is protecting the FRR, but I see the value of that. I mean, so your draft is pretty much formalizing what IGP is doing, but it goes natively into Bier. And
yes.
it has value if you, for example, so I mean, the compression is neat, but I don't even know whether it's necessary, but sure. But I think to put it natively into Bier has the value because if people start to program BIFs over controllers or not use IGP or anything like that, this is of course a very useful technology. So I kind of changed my opinion. I think it has a certain value. It explains really much what IGP is doing anyway. I think in a more obvious way, but it's not a bad thing actually. Yeah.
Excellent. Thanks, Tony. Yeah, I agree. That's the environment where you're doing controller programming. You still need the functions that you don't get with an IGP. It makes lots of sense.
Yeah.
All
and
right.
so was that
Next
just
here.
comment? Was it an adoption call? What was the last slide? Waimo, you seek.
There's another slide. I'll go quick.
No, do you seek just comments or do you seek adoption?
I think both. if okay, and then we can go because this is experimental.
So Greg, I think we should have a vote. Can you start?
Let's do a vote then. All right. Let's turn that off. I'm going to start a session. There it is. All right. And this was. I added a G. Sorry about that. Typing quickly. So this is a FR draft adoption call. Thinks this is. Thanks, Tony. We have a couple of objections.
Okay, so objections, please, on the mic, because we have to understand why the objections. So we have 42, okay? Please, comments on the mic. People have two hands, and I think that confuses them. No, you cannot push both buttons.
Okay. Can I go?
Yeah, go for it.
Yeah, go for it.
My understanding is that Bier, one of the idea of Bier is that does not create a state in a transit node. FRR requires a state in a transit node. So
no, because we don't have any per flow state in the transit node.
No, because you cannot protect without knowing your next hop. So you're protecting for the specific flows that are controlled from the BFIR. And
we have a extended forwarding table. We call the FR forwarding table. We only have this forwarding table is a limited size, and then we don't have a per flow state.
But that's exactly what is a state in a transit node.
Yeah, but
So-
Greg, we already have, I mean, we have BIFs. This is just a bigger BIF. This is not the per flow or a tree, right? And how much
Yeah,
they
that's
do.
right. Yeah,
Right.
that's right. That's limited size. The size is limited. Not per flow states. That's a difference.
If we run IGP and Protect, we have exactly the same state, just in a different form, depending on the
Yes.
implementation, to be honest. You know, this is what IGP is doing anyway. It is just folded into bits. Okay, I'll let
Yes.
other people speak. So let's have a discussion. That's a good one.
Yes.
Yes, please.
Can I just ask a quick question here, just to ensure that I'm in sync with my understanding? So I just want to understand, the proposal here is just to use the IGP mass reroute, nothing else, right? So all we are doing here is that if IGP gives you a protection next hop, you're using that protection next hop, whether it's actual next hop or LFA or remote LFA or whatever it is. Is that it, or are you guys actually creating a second Bier table for the fast reroute?
Yes, you see, we have a FR forwarding table for each next hop. Because IPFR using IP forwarding table. Bier use Bier forwarding table. So that's in different forwarding tables. So for Bier, we need a special enhancement for the Bier forwarding table to provide faster protections.
Is the queue actively managed by the chairs?
Yes, but Human jumped it, and I probably should say something, but it's productive. Told as you get to it. So
Yeah,
Human,
I think the Bier taste check is kind of the stateless check, right? That something does something really smell like beer? Is does the state in the transit hop changes when a sender becomes active, goes offline, or receivers appear or go away, right? Does that change the state on the transit hops? And I think when it does not, then it tastes and smells like beer, and that's why this tastes and smells like beer.
yeah, I mean, I like beer smell otherwise, but yeah, I agree. That's a good one. So Human, did you clarify that? Otherwise, please take the mic.
Yeah, somewhat. Like, I think my point is that the Bier next hop, the BIF is built from IGP anyway, right? I mean, you grab the IGP information.
No, the architecture does not tie us to IGP. That's what we grab, and it's one type of signaling, but the architecture is independent. There are people doing the whole BIF stuff over controllers or CLI, and we don't preclude that.
So I agree on that, but then we're going to have multiple type of fast reroutes, right? One fast reroute is going to be just IGP is going to give you a protection next hop, whatever that protection next hop is going to use.
I think it's up to the draft to explain, right? What happens if you run IGP, right? When do you use technology?
And I'm good with all that. My entire point here is that it would be beneficial if we agree on one type of fast reroute protection, right? So I mean, in IGP or any type of other technology, you have ECMP as one type of protection, and then you have bypass or fast reroute as another type of protection. Having multiple ways of skinning this cat would create issues of interrupt, etc., etc. That's all my point. Yes, we definitely need.
The draft must be very explicit about the stuff. So when you run IGP as signaling, this draft will probably say do not use that. But if you don't have an IGP and you need protection, here's your solution. And I think it fits fine into the architecture, but it's just my take, right? So I don't see them adding state. I don't see them breaking architecture. Actually, I see them, in a sense, the draft to filling in a possible gap in the architecture if somebody wants to use it without IGP. More people on the mic?
All right. So I'm trying to add the next deck and it's not letting me share. I get this error over and over. It's like it starts and stops. So I don't know if someone could try to use that.
You
Maybe
try
Ken
to
can
share,
grab it himself.
I see that the Bier FRR adoption was 8-1 at the end.
Yeah.
So pretty clear. We take it to the list and basically start an adoption call. I say a discussion about a possible adoption call. Okay, thanks. I take
Great.
note.
All right, Chen, can you grab this deck yourself? I can't seem to bring it up now. Micheko is giving me an error. Request is not allowed by the user agent or in the platform in the current context. So I don't know what state I'm in, but it's not letting me share a document now. Anyone? Tony, can you hear me? Wow, no one can hear me now?
Yeah, I can hear you.
Okay, gotcha. So, Chen, I'm trying to bring up the next egress protect draft, your presentation, and it's not letting me share it. So if you can grab it yourself from the tool, or if Tony can bring it up, that we can get this next deck going.
Taking notes, just give Sandy the screen. Sandy, can you project, please?
Should I share a screen for Huanmo?
Yes, if you can get the last two presentations up and then do a share screen and run through them. I'd have to disconnect and try again because I'm getting an error every time I try to share a screen.
Okay, let me try.
Yep, you're granted. There you go. Wow, it lets me grant you, but I can't share my own.
Oh, I'd like to choose. Okay.
Yeah, you may be having some bandwidth issues. Oh, here it
Can you
comes.
see
All
it?
right.
Oh, great. Thank you. Eventually, we
Okay.
got the screen. Good, good. So basically, this is about the Bier equals protection. Next page. So we made some updates to the previous version. So we just more details about difference from the existing one and some editorial changes. So next page. So here, the difference that our draft just for provide egress protection, we just use one path from source to egress node. But for existing MOFR, that use two disjoint paths from source to each of the egress node. And then the egress node will select one of the traffic, because two same traffic from source to the same destination. So the destination will select one of them. So in this sense, so our egress protection will use less network resource than the existing one. So next page. So for this one, I think we will welcome more comments because adoption, because we'll have more options. For example, Jeffrey proposed another solutions for egress protection, and then we need more discussions, maybe merge or whatever in next step. Thank you.
Yeah, from my side, as chair, I think you should huddle together with Jeffrey, and you guys should talk it out whether you want one single draft and then explain egress protection for the different cases like helper and this case, and whatever we have, and possibly even for PE protection, egress protection into the same document.
Okay, thank you. Yeah.
Sorry, there's something wrong.
No, it showed starting.
Can you see it?
Yeah, it's good. Yeah.
Okay.
Yeah.
Okay. Because the time limit, I will do a very quick update. Hello everyone, I'm Sandy Zhang from ZTE. This presentation is for the update of Bier redundant ingress router failover draft. We have co-author Greg Chen and Yisong from China Mobile. The update of this version is that the title of this draft is changed from Bier source protection to Bier redundant ingress router failover because the new name is more accurate and suitable. And in the new version, we added the reference to the draft which discusses the redundant ingress router failover issue in MBOND working group. This draft analyzes the issue in Bier domain. In this version, more description is added, and such as the issue analysis, the node failure detection, the working path failure detection. The following pages has been presented in several meetings, such as the 108th meeting. So I will skip them very quickly. If you have some question, you can ask me to answer it. Maybe just skip them to the last page. So this draft has been presented in several meetings. So and it's an informational draft. We think this draft can give some guidance for Bier deployment. If working group approves, we'd like to request working group adoption. Thanks. Any comments? Hello?
Yeah, we're here. Greg, you start a call. Who I'm with on the mic?
Yeah, I'll start a vote on this. Where'd it go?
Yeah.
Go hands tool. There we go. Thanks.
Yeah, one more. Go, please go ahead.
Yeah, I wonder, in the draft, you mentioned that you have a PFD for detecting failure of the node inside the Bier domain. Why do you need that for ingress protection?
Sorry, you mentioned what?
So in the draft, the draft, you describe a lot of things for detecting the failure inside the Bier domain. So this seems not directly related to the redundancy ingress node or ingress protection, something like that.
No, because all the
if I may,
function. Okay,
Sandy.
Greg, please.
Yes, yes, Rama. So because there is a redundancy in BFIR, so point-to-multipoint BFD can be used by BFERs to detect the failure of their active source and then change it. So if you can suggest any other way to detect the failure, that will be much appreciated. But we don't have any other IETF standard mechanism to detect the failure in a multicast rather than point-to-multipoint BFD.
So I think in the draft you also describe the detection, the failure, for example, a transient node in the network for the BFR.
It's the same. It's the same because for the BFER, the failure is indistinguishable. What the BFR detects is the segment of the multicast distribution tree is not working. So because how point-to-multipoint BFD works is that the root sends periodically control packets so that the leaf or tail in terms of point-to-multipoint BFD knows from the previously received packet and calculates their failure detection interval. So if there is no control packets received, BFD control packets received within this interval, the leaf declares the network failure. And that equally applies either to failure of their root or the failure of the distribution path. So there is no need for their egress to differentiate two types, because there is no repair. Because in this use case, there is alternative source of their data traffic. So for the leaf, it's simple to switch to the alternative source. Does that answer the question?
No, I mean, I think you have description about detect failure of a node inside the Bier domain. I think that part may be not necessary, right? You can detect the failure of a source, and that's for sure. That's good. But you don't need to detect the failure of a transit node inside a Bier domain, right?
Why? If it's a transit node essential to distributing particular flow, we're detecting it, and we are not differentiating. Again, I want to stress, we are not differentiating the failure of their root, the head of the multicast tree, from the failure of any segment or any transit node. From the standpoint of BFR, so there is no need to differentiate these types of failures. So what detection is that it stopped receiving for certain interval BFD control packets, and that's interpreted as a failure of their distribution tree and triggers some switchover action.
Okay, cool. I see the poll being 9-0, so we take that to the list.
Thank you.
Thank you, Sandy. All right, that is all we have on the agenda. We are already 12 minutes over and no one has cut us off. This is pretty exciting. Blue sheets don't exist because you've already signed up. It's been done. We got Jeffrey and then on to Tony, I believe, that finished up the notes. Was it Tony?
Done.
Got it. All right. We'll see that in email. Any other comments before we move on? And you go off to your lovely day here in Prague? All right. Thank you very much. Productive meeting. You guys have a great week here.
Yeah, thank you very much.
Cheers.
Yeah, thanks for participating. That was a great one. Later.